let me think about this for a second. So we're going through the hash values of the sigma k's. And then we get the hash key j. And then for each of those, we get tau from the SGS. Okay, so that's where that's from. So our S here is for S sim. This is going to be equal to the sigma symbol of K and J. And then we do this stuff. But we still need, of course, the representation of everything in the SGS. So the SLP here is a composed SLP. Our first one is something tau, which I haven't figured out how I'll do yet. And the second one is our S sim. So SLP symbol of S sim. You know what? I'm going to modify this to have an optional SLP. That is what I decided I'm going to do. And down here, update transversal, this will take an SLP. So these optional arguments here, yeah, that's how Lisp is. We're assigning ssim to the sigma symbol. So anyway, these SLP arguments, this SLP describes how we will construct this permutation here. So, yeah, that's all it is. This SLP describes how we construct this permutation. So actually, what we can do is take out this, and what we can do down here, when we call add generator, we still need our free group fg generator as 0. We call add generator on generator, the empty SGS, the empty, or not necessarily empty, trans, and then our representation of this generator right here is just a SLP element of our incf FG generator. So we can take this out. I don't know if that made sense. So I added optional arguments here, SLP arguments to both these. And what this SLP refers to is the straight line program used to construct this perm. Likewise here, this SLP right here is used to construct this permutation. So what we're doing when we call add generator here is we have a single generator, while the SLP to construct that is just a single SLP element with our generator number that we increment each time. So that's all it is. And then we'll slowly add assignments to this. So one assignment that we can make right here is we setf our what is it? What did I call it? I am really bad at remembering names that I created. Symbol assignment. Our symbol, or our assignment, is assignments, and our symbol is sigma symbol with K and J. And like I said, perm, which is here, refers to the straight line program that we constructed here. So we're assigning the SLP for that. The new perm SLP here is going to be the inversion of the sigma that we have here, which is just kj. So we compose our SLP, invert SLP, and this is just the sigma, so we need to make a sigma symbol. SLP symbol of k and j. And then we multiply that by the permutation, which is just whatever SLP we passed into it. So, okay, let me go through this. This new perm right here, we're doing some computation. We're doing a composition of an inverse of some sigma, followed by, with the permutation. The idea here is that we need to compute the SLP as well that computes this. So this right here is the exact same thing as this, except we're working on SLPs. We're doing the inverse of the sigma here, which is right here, and then we're composing that with the SLP that constructs this perm. But that's passed as an argument here. So that argument we just put here and compose SLP. So we have this new permutation SLP, which we will pass in. This new perm has a new perm SLP as well. All right. So I think this function is done. I think we are good here, except add generator is called with, okay, that's fine, because we need to update this one over here. So we need to have this prod SLP right here. We need to update the transversal with the new prod SLP. And finally, we need to have the representation of all of the k values, or all of the SGS values. So the last thing that we need to do, the final last thing, is to figure out what the SLP is for tau here. We could do this in a variety of ways. We could either assign the SLP within the list, or how should we do this? So the only way the SGS is getting modified here is by way of pushing a permutation onto onto this thing. I don't even think we should have push new here. Maybe it should just be push, because I'm not actually testing equality. So I hope this doesn't break my code, but I'm going to change it to push. We can also make a tau symbol, and what that's going to do is have k here, and the element in this list right here that it exists as. That maybe sounds complicated. I think I have a better solution. Defvar taus. This is going to be another code smell global variable. I'm going to keep our push new here, but our taus are going to be a hash table mapping permutations to their symbols. So watch this. Watch this expert execution right here. Taus is going to be a make hash table. Make hash table. Maybe this won't be such an expert execution. Let me think. the taus are probably going to be, I think they're going to be unique, but they may not be. So test is going to be EQ. Let's bind these taus right here. And you can just in Emacs do it. I'm not going to write the tau symbol in here because some common Lisp implementations barf when it outputs symbols to their standard terminal I/O stream. This bit me at a company I worked for previously when it tried to output Unicode characters to their terminal output, terminal I/O. For example, during compilation, it would have a warning about a variable that was Unicode, and but then that warning about the Unicode, when it tried to construct a string to print out, it itself went and errored. So I'm not going to use Unicode, which is a shame because I like using Unicode in my code. So taus are pushed onto this thing, but we're also going to create a new tau value, a new tau symbol. So I'm going to make something called tau symbol, define tau symbol. It's kind of like gensim. In fact, it might as well just be gensim. Gensim with tau. It doesn't need to be a keyword. I mean, even in LispWorks, when I did maybe this will make it work. I mean, I don't know if I tried all of these variables right here, but in LispWorks, when I contacted the people there, they told me that they would have to re-implement their terminal stream implementation in order to support Unicode, which they haven't done. So that's kind of the brief story, but that was their claim, that they themselves didn't support it, but maybe I didn't communicate my problem very well. So here we want to associate this perm, so setf get hash let's see, how should we do this? Setf, so the keys of this thing are the permutations themselves. The let's see, taus. Yeah, right. The keys of this are the permutation themselves, where the identity function is just basically its address. The values are going to be new symbols representing the tau. So let me do this. Let tau sim. I'm just going to call it tsim, tau symbol. We set up the taus to be tsim, but we also need to teach our we need to set that assignment. Set up symbol assignment of our assignments to be the symbol tsim, and the value is the perm, which is the SLP. So now that we have the tau symbol, when we iterate through each of the taus here, we can get the tau symbol. So we can get SLP symbol. Let's make this a let star. Let's do tsim be the get hash tau